Okay, today we will discuss about beta distribution. Now, what is your beta distribution? So to give you a brief definition or background about this, your beta distribution is a family of probability densities of continuous variables taking on values interval of 0 to 1. So this is now your interval with two parameters, A and B. So these parameters of yours appears as a exponent of your expression or your beta distribution, and it controls the shape of your distribution. Now, to give you the concrete mathematical definition about beta distribution, so this is the one. If a random variable x has a density given by f sub x of x equals f sub x of x given a and b is equals to 1 over b of a and b times x to the power of a minus 1 times to the quantity of 1 minus x, b minus 1, indicator of x from 0 to 1. Now, of course, your a and b is greater than 0, then your x is defined as a beta distribution. Now take note of this expression of yours. Your b of a and big B of a and b is your beta function. Now what is your beta function? It is defined as it is equals to the integral of x to the power of a minus 1 with times to the quantity of 1 minus x raised to the power of b minus 1 dx integrated from 0 to 1. Of course, as usual, your a and your b is greater than 0. Now, regarding about the beginning of this thing here is that it is from the normal theory, or in normal theory, the beta distribution arises naturally as the distribution of your v squared equals x sub 1 squared over x sub 1 squared plus x sub 2 squared. And this whole thing here, your expression, the thing that comprises your expression, are all independent variables. And another way is that your beta distribution is from the distribution of an ordered variable from a rectangular distribution. Now, to give you the illustration about beta distribution, it is in this way. So think that you have a crush, or if you think that you have the chance, or your chance to date your crush is just 0.33 rather, or equals to 33% chances to date your crush. Now your friend thinks that the chances you have are 0.5, 0.2, 0.25, 0.6, or 0.65. So after hearing their opinions, you are then not sure, or certainly sure, that the probability to date your crush is 0.33. So rather, you think in some chance that the value of the probability to date your crush is higher or lower. So it may be like this. It's either up or down. And this personal belief of yours, it can be described as a beta distribution. So that's it. Now, how does it make sense to study beta distribution? So we may think this this thing of this complicated expression, or this complicated mathematical definition, how does it make sense to study this thing? Beta distribution has been applied to model behavior of random variables limited to intervals of finite length in a wide variety of disciplines. So examples are: it is used as the statistical description of other frequencies in population genetics. Of course, in time allocation, in project management, sunshine data, variability of soil properties, proportion of minerals in rocks, in stratigraphy, and heterogeneity in the probability of HIV transmission. So that's the application of your beta function. Now, let me give you the remarks of this thing. So we have the remarks that our beta distribution is reduces into a uniform distribution. So what is this uniform distribution? It is when your beta distribution is reduces over from your interval 0 to 1 when your A and B is equals to 1. And the second one is the cumulative distribution function is a beta distributed random variables is expressed in this way. We have f, big F, sub x of x, A, and B equals the indicator of x from 0 to 1 times you have your integral of 1 over b of AB times u to the a minus 1 times the quantity of 1 minus u raised to the power of b minus 1 integrated from 0 to x plus indicator of x from 1 to infinity, and it is often called as incomplete beta function and has been extensively tabulated, done usually by means of specialized computer algorithm. So now I want to give you an example about this thing. So we have this. A production plant produces items that have a probability X of being defective. The plant manager does not know X, but from past experience, she expects that this probability to be equal to 4%. Furthermore, she quantifies her uncertainty about X by attaching a standard deviation of 2% to her 4% estimate. After consulting with an expert in statistics, the manager decides to use a beta distribution to model her uncertainty about X. How should she set the two parameters of the distribution in order to match her priors about the expected value and the standard deviation of X? Now, in this problem, or in this example, we will find the value of your parameters, which are your A and B. Now, how to do that? Let me show you. So we know that the expected value of beta random variable with parameters A and B is, we have expected value of X equals A over A plus B, while its variance is expressed in this way. So variance X equals to AB over A plus B plus 1 times the quantity of A plus B squared. The two parameters need to be set in such a way that your expected value is equals to 0.04, and of course your variance is equals to, you can express this variance in this way. We have this of X squared, or simply we have 0.02 squared, or equals to 0.004. This is accomplished by finding a solution to the following system of two equations in two unknowns. So we have this system. We have our A over A plus B, or simply your expected value is equals to our mu, and our variance, which is expressed as AB over A plus B plus 1 equal times to the quantity of B squared is equals to our sigma squared, or our standard deviation, where for notational convenience we have to set this thing. Now our mu will be equals to 0.04, and our standard deviation, or our sigma squared, will be equal to 0.004. The first equation give us, of course, this. We have A equals to mu A plus mu B, or simply it is equals to B equals 1 minus mu over mu times A. Now, by substitution, we get this thing. Wait. So we will substitute this thing here into our variance formula. So we have var of x equals ab over a plus b plus 1 times the quantity of a plus b squared. So by substitution, we will now get 1 minus mu over mu a squared over a plus 1 minus mu over mu a plus 1 times a plus 1 minus mu rather a squared. So this is now equal to your sigma squared, and or it can be rewrite as in this way. We have your a squared over 1 minus mu times a plus 1, or 1 over times 1 over mu a squared, or just simply as mu over 1 minus mu times your sigma squared. Then we divide the numerator and the denominator of the left hand side of by this thing, or it is equivalent of having this one. We have to multiply a squared, and now we can come up into 1 over 1 mu a plus 1 times 1 u squared, or simply equals to, of course, this thing, nothing has changed, u squared 1 minus mu times, of course, your sigma squared. So by computing the product of this whole thing here, this will be equal to 1 over mu, this mu here, not u, cube a plus 1 minus mu squared equals mu over 1 minus mu sigma squared. By taking the reciprocal of both sides, we now have, of course, just simply 1 over mu square cube rather a plus 1 minus mu squared. Since nothing has changed, just over 1 here, so we don't need to write that one. And we have, of course, 1 minus mu over mu times your 1 over sigma squared. And after that, multiplying both sides by, of course, mu cube, we then arrived a plus mu equals mu squared minus mu cube over a sigma cube squared rather. Thus the value of our a is equals to mu squared minus mu cube over mu rather your standard deviation sigma squared minus mu. And the value of our b now is, for finding b, is 1 minus mu a. Recall that our b here, wait, here your b is equals to mu over mu, sorry, it's a here. And by simply having a substitution, we now have 1 minus mu over mu. Of course, this thing here, you write it or simply it's just wait as 1 times mu, sorry. Just simply doing simple algebra here. Squared equal minus 1 minus mu, and this is simply equals to mu minus mu squared plus mu cube over sigma squared minus 1 minus mu. So just simplify, we then have mu minus 2 mu squared plus mu cube over sigma squared minus 1 minus mu. So this is now your b. So this is your the value of your b. And for your a, we then have something here. Here, your a. So by simply plugging our numerical values into the two formulae rather, so remember that our mu is equals to 0.04 and our sigma squared is equals to 0.004. Now we can now get the values of our a equals to 3.8 and our b is equals to 91.2. So in addition, for an example, your beta distribution is used to describe the initial knowledge, such as the probability that a space vehicle will successfully complete a specific mission rather. So I think that's it. I hope you have learned something about beta distribution. God bless.